Right, a quick recap then on discrete random variables. We saw that discrete data was data that could be counted. Random, everything, all the data had an equal opportunity of happening. So when we flip a coin or roll a die, that is a random process. Days of the week or months of the year, if we're choosing from those, then that is not a random variable at all. We looked at the Monty Hall problem and we'll be able to solve that by the end. We looked at some definitions, variable, sample space, we've seen that before from earlier chapters. And then we went on to do a couple of examples. We did our definitions and then we also tried to identify discrete random variables. That table there is called a probability distribution table, and the little x was what the outcome was, and the p of x equals x was the outcome for that specific, or probability for that specific outcome. We did a sample space, so that was flipping 3 coins. We had a look at that, and then if we look at part C here, part C is a probability function. So it was described in terms of the probabilities and the outcomes, just in a different way. So all 3 represent the same thing. The thing that we did was the sum of all the probabilities added up to 1, so it allowed us to work out values of k. So what we were looking at was this part here, and that part meant the sum of all the probabilities adds up to 1. Right, next part. We did a few questions. We'll skip over the questions, and then we were actually trying to find probabilities. We had to be careful with the inequality sign, and one of the things that was useful to have a look at, that if the probability was in between 1 and 5, it was the same as 2 and 4. So those inequality signs were really quite, you have to be quite precise with them, is what I'm saying. Okay. Then we did a couple of questions on that, and then we went on to the cumulative distribution function, and that's what we're going to concentrate on today. Cumulative just means a running total. It adds up as we go along. We've done cumulative frequency before, but this time we're just applying it to the probabilities. And the major thing that we saw last lesson, and that's what I want to re-emphasize, is that the probability of the last event, or the last outcome, is always 1, because all the probabilities add up to 1, don't they? And so on. So let's work out the next part that we're going to do today. Then we have a little example. Example 8, can we have a look at, please? You will find that on page 11. Is that okay? We've not done that yet, have we? No. Okay, right. Right, here we go then. The discrete random variable, so we know what it is, discrete random variable, has a cumulative distribution. So cumulative distribution is represented by capital F. So you know that you're adding them up this time. And we've been given the function of it, f of x is equal to x plus k over 8. And we've got a few distributions here. Right, let's see if we can find out the value of k. Now, thinking back to the table that we had before, the last outcome, so the last outcome in this is 3. What do all the probabilities add up to at that point? If you what do all the probabilities, what's the cumulative probability at the very last outcome? 1, yeah. So what we can say for part A then is f of 3 is equal to 1. Happy with that? So that's everything up to the end. So because when we're doing a table, and we're going to do a distribution table, what I'm saying here is that we have x and we have f of x, so it's 1, 2 and 3. I know straight away that I can put a 1 there. So all the probabilities, running total of all the probabilities is going to be 1 just at the very end. So if we put that in there, that means that x, that value there is when x is equal to 3. So we get 3 plus k over 8 is equal to 1. Cross multiply gives you 8, so k is equal to 8 minus 3, so k is equal to 5. So that's part A. From there we can do a distribution table, and this can be B and D, because underneath we could put the probability distribution as well. So capital X equals X. Okay, let's have a look at what we're going to do then. For x equals 1, we've got f of 1 is equal to 1 plus k over 8, which is 6 over 8, which is 3/4. So f of 1 we can put in 3/4. For f of 2, it's going to be 2 plus 5 over 8, which equals 7 over 8. So that's our cumulative, where we add up. Right, part C then. Write down f of 2.6. Right, there's a problem here. We don't have a 2.6 on the table. Which one can I only go to? Which one would you say that that's exactly the same as? F of, I've not got a 0.6, it's discrete data, it has to be a whole number. And if I say to you we never ever round up, then that has to be f of 2. So for discrete data, never round up the cumulative distribution function. So that's key. I can guarantee that'll be asked in an exam, because they're testing whether you know what to do with discrete data. So if we look on a table then, f of 2 is this one here. So that's going to be 7/8. Okay, so for part D, we want to find out what the individual probabilities are. So the probability of x equals 2 is going to be the cumulative of 3 minus the cumulative of 2, and that's simply 7/8 take away 6/8, so that's going to be an 1/8. So we'll put an 1/8 in there. That one stays the same, it's 3/4. Now you've got an option here, you've got a couple of things that you could do. You could either do 3 minus 2 to give you this one, or we know these all add up to 1, so we can find out the other one, okay? So we've got 6/8, 1/8, and you can do that in your head. It should just be an 1/8 as well. So the sum of all these probabilities adds up to 1, so that's your double check there. Is that okay? Happy with that? Right, to practice that then, that's going to be exercise 8B, which is on page 12, and I'd like you to do questions 3, 5 and 7, and then I'll give you the answers, give you 5 minutes to do that. Okay, so that's the solutions there. If you have a quick look, make sure that you've got the right answers. It's a bit crowded in there, I need another page really. And the key thing that you need to know is the probability is represented by P, and the cumulative or the running total is represented by F. Right. Moving on to the next part then, we have got the mean or the expected value. These are the same thing. The mean or the expected value or expectation are exactly the same thing. So what do we have to do? We have got a little formula here. So the expectation or the expected value is that. And you have to memorise that. Expectation is in a form in the formula booklet, but just make sure you know what it actually means. So if you've got a statistical experiment, a practical approach results in a frequency distribution. So what we mean by that is if you roll a die 100 times, then you get a frequency distribution. You get how many 1s, 2s, 3s, 4, 5s or 6 that have been thrown. So that's your expectation, your expected values from that. So frequency distribution. And from that we get a mean value. And the theoretical approach is an expected value. So you can do the theory from it. Right, what do we get then? We've got the number of TV sets per household in a survey of 100 houses in a town gave a following frequency distribution. So you can see there's your frequency, and the number of sets. 3 TVs in a house. 3. That's a lot, isn't it? Some people have got none there. So it gave this frequency distribution. We want to find out the mean of this data. Now thinking back to what we did before, let's do part A. The mean is X bar, and it's equal to frequency times the data. So that's going to be the X's. So that's your X there, and that's your F there. And it's all over the sum of the frequencies. So we know that we've been given 100 altogether. We've been told that in the question. If not, we would add these up to get the sum of the frequencies. So it would be 10 plus 75 plus 10 plus 5. So that's a good check just to make sure that you've got 100 there. But we're told in the question. Then we want to do F times X. So the first one is 10 times 0 plus 75 times 1 plus 10 times 2 plus 5 times 3. So X bar is going to be equal to 110 divided by 100. Don't think you need a calculator for that one, people. 1.1. And you leave your answer like that. It's roughly the mean, or the expectation is that every household will have at least one. Okay? Right, part B then. Draw up the probability distribution table for the variable X, where X is the number of TV sets in a house, picked at random in the town. So this is a discrete random variable. We've got the table here. That table is not usually given to you. Okay? It's not usually given to you. So let's see if we can work this out then, the probabilities of each one. So if we look at the probability of 0, from the table above we get 10 out of 100, which is equal to 0.1. So 0.1 goes there. Sorry, that should say 0. If we look at the probability of 1, that is 75 out of 100, which is 0.75. and if we do the others the same, it's 10 out of 100, so that's 0.1, and then 5 out of 100, which is 0.05. And your check there is that all of those should add up to 1. Yeah, and that's all we're looking at. Now, instead of from the table that we first looked at the top here, so instead of finding out what the mean is from this data, we can now use this probability distribution and find out the expected value. And that's what we're going to do. We're going to write down our formula. So as I've said before, when you've been given a formula, you write it down and then you substitute your values. So for part C, the expected value is E of x is equal to the sum of the little x's times the probabilities, and you have to know this. So that there, learn that. And you're doing exactly the same thing. You're just multiplying the columns, the numbers in the columns together and adding them. So in this way, this is to be the sum of 0 times 0.1 plus 1 times 0.75 plus 2 times 0.1 and 3 times 0.3 times 0.05. And when you calculate that, it will give you 1.1 as well. Do not expect to get the original data. Just expect what you'll be given is this table B, and you'll be asked to work out the expected value for x. Okay, so just showing you that the two methods, the first method is what we've used before with group data, with a frequency, but you won't be given that in the discrete random variables. It's just going to be that one. Right, let's try an example of this then. We have the random variable x has a probability distribution given in the table here. Given that E of x is equal to 3, write down two equations involving P and Q. Now what we've got to think about is two things that we know that we can work out. What do all the probabilities add up to? 1. So that's one thing that we could write down. So all the probabilities add up to 1. Can you form an equation with that information? So that tells me that 0.1 plus P plus 0.3 plus Q plus 0.2 is equal to 1. Let's tidy that up. And that means that P plus Q is equal to 0.4. And we'll call that equation 1. Yeah, we've got two unknowns. We need two equations to solve them simultaneously. Right, the next thing that we know is that E of x is equal to 3. Well, we also know that that is equal to all the x's multiplied by their own probability is equal to 3. So can we work those out and we'll get another equation with P in it. So that tells me that 1 times 0.1 plus 2 times P plus 3 times 0.3 plus 4Q plus 5 times 0.2 is equal to 3. So we simplify that again, and we're going to get 2P plus 4Q is equal to 2. So we get 2 on that side, so 3 take away 2, which is 1. So we'll call that equation 2. Okay, so we've got two equations involving P and Q, and then for part B, what I'd like you to do is solve them simultaneously. So going back to what we've done in C1, you've got two equations, two unknowns. I multiplied the first one by 2 and then solve simultaneously, so we get the two values of P and Q. 0.4 minus 0.1 is actually 0.3. Thank you very much. Right, I want you to try a couple yourself then. So on exercise 8C, I'd like you to do question 1 only for e of x, so not e of x squared. Okay, so don't do that part of it. So that's question 1, and then the same for question 2, just e of x only. That's what I want you to try out just now. Okay? And if you can, we've got about 10 minutes, you should be able to finish that off. If not, we'll do that for Friday. So for question 1A, the e of x was equal to 4.6, and for part B, expected value was 2.8, and then for question 2, expected value was equal to 4. Right, we sometimes want to find the expected value for x squared. So that's our last little bit, and then you should be able to do just the other parts of the question for the previous exercise. Okay, what does it look like then? Instead of x, all we've got is x squared in there instead. And the only thing that changes is that you've got to work out what x squared is. So I've put a table together for you down here. And if it's raised to more than x squared, if it's x cubed, well, you just cube or to the power of 4 your value and do exactly the same thing. So we've got our probabilities there as well. And what we do is we just square our x values. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And then we want to work out the probabilities of the x squared, which are just the same. By squaring them, it doesn't make any difference. So we just take our values as we did before, and 3 out of 25. And then from there, so that's part A, we've done the probability distribution for x squared. And then for part B, just finding out the expectation and the expected value of x squared. That's just the sum of the x squareds times the probability of the x squared as well. We don't particularly need the squared in there because it's just the same as the x's. So from there then, we get 1 times 12 over 25, so that's your first one, plus 2 times 6 over 25, plus 3 times 4 over 25, plus 4 times 3 over 25. So using... Oh, sorry, I've done the wrong thing there, haven't I? Thank you. We should have 4 there. Whoops, that's the wrong one as well. Having a good time here. That should be 4. Sorry, that should be 4, that should be 9, and that should be 16. Thank you. Read the wrong bit on the table, haven't I? So when those all get multiplied together, we get 120 over 25. Therefore, e of x squared is just simply 4.8. Happy with that? So on that exercise 8C, can you do question 1 and 2 for the e of x squared? And can you finish that for Friday, which is the 20th, yeah? Yeah, 20th of Jan. Okay.